Hello guys, welcome to my channel. Please, after watching, please don't forget to subscribe, even like, comment, and also share these videos with your friends or even your classmates. What we have today, we are given the question on a matrix, right? Given that matrix M is equals to 1, 1, 1, 1, 1 minus 1, then minus 1, minus 1, 3. Meaning that this one is a 3 by 3 matrix, right? Then first part A, find the this symbol. This symbol means you have to find the determinant of matrix M. So this means determinant under matrix. So this means you have to find determinant, right? Find determinant of M. Then B, hence or otherwise. Hence or otherwise, find M to the power of negative 1. So M to the power of negative 1 simply means the inverse of matrix M. But we have given hence or otherwise. Hence simply means use answer from above. Hence means use the recent answer, the answer from above. Then otherwise, you can use alternative method in order to find the inverse of matrix M. Right. Then the last part C, state the name given to the matrix with the determinant 0. We are asked to state the name given to the matrix with the determinant 0. If you calculated the determinant in the solution becomes 0, so you have to state the name given to that type of matrix, right? So we want to focus on finding the determinant of matrix M first. Let's find the determinant of matrix M first. Right, we are given M is equals to 1, 1, 1, then 1 again, then 1, negative 1, negative 1, minus 2, 3. Right, this one is our matrix M, right? We want to find the determinant. From the recent video, we have applied two methods to find the determinant. We have the first one, what you call method of cofactors, right? We have the method of cofactors. Then we have another method which is basket width method, right? So we want to implement what we call a method of cofactors in order to find the determinant of matrix M. So we are saying positive 1 is multiplying, positive 1 is multiplying the determinant of this matrix, which is 1, minus 1, minus 2, 3, right? Then minus 1 is multiplying. Remember, we have these signs, positive, negative, positive. We have to apply those signs in order to find the determinant using the method of cofactors, right? So we are saying positive is positive, the negative is negative. So we have negative 1 is multiplying the determinant of this outside values, which is minus 1. Here is minus 1, which is 3, plus the last one plus 1 is multiplying 1 here, 1 here, minus 1, now minus 2, right? So let's now simplify in order to find the determinant of M. Determinant of M. So we are saying positive 1 is multiplying. Remember, we want to find the determinant of this 2 by 2 matrix and also the determinant of this 2 by 2 matrix, and finally the determinant of 2 by 2 matrix. So we are saying we have a 1 here. So we have 1 by 3, we have 3. So 3 is subtracting minus 1 times minus 2, which is subtracting 2 here. Then minus 1 is multiplying this one by this one, we have a 3 here. Then is subtracting a 1 here. Then plus This one we have minus 2 here. Minus 2 is subtracting minus 1. So we are saying a positive 1 is multiplying a 1, minus a 1 is multiplying a 2, plus a 1. So plus a 1 is multiplying minus 2 plus 1, which is negative 1. So what we have is with 1 here, minus 2, 1 minus 2, minus 1. So we are saying 1 minus 2, which is minus 1. Minus 1 minus 1, which is minus 2. So meaning our determinant of matrix M, our determinant for matrix M is negative 2. Here is our determinant for matrix M, right? Here is determinant for matrix M, which is negative 2. Let's move on part B. Here is part A. We are moving on part B. Hence or otherwise, find the inverse of matrix M. Right? We want to find the inverse of matrix M. But already we have our determinant. Our determinant now is determinant of M. Determinant of M is equals to negative 2. Here is our determinant of M. So you will be awarded 2 marks for calculating the determinant using either basket-weave method or this method of cofactors. Here we have applied the method of cofactors. You can also apply the basket-weave method in order to find the determinant of matrix M, right? We are moving on to the inverse. We want to find the inverse of matrix M. Moving on to the inverse of matrix M. Inverse of matrix M, said we have is moving on part B. Here we have the matrix M. Here we have the matrix M, negative 1 here, negative 2, 3. Here the matrix M. Here the matrix M, and you want to find the inverse. So the question said hence or otherwise. Hence means simply means use the solution from above. Otherwise, you can use alternative method in order to find the inverse of matrix M. So want to use the hence part. Want to use hence part. Hence simply means using the solution from above, or the recent solution is calculated. So we have calculated the determinant of matrix M here. The determinant of matrix M, negative 2. So we want to use hence part, whereby we are going to use this determinant of M in order to find the inverse of matrix M. So what you are saying is, for us to find the determinant of matrix M, let's keep our determinant. We have to implement this determinant of matrix M, which is negative 2, at the end of working in order to find the inverse of matrix M. So what we have to do is, first of all, we have to find what we call a matrix of minors. So we are saying 1 here, 1 here is collecting those outsiders values. So we are saying 1 is collecting 1 minus 1, sorry, 1 minus 1. Alright, 1 is collecting minus 1, minus 2, and 3. Right, then 1 between is collecting 1 minus 1. 1 minus 1 minus 1, and also a 3. Write it this way. Write it this way. Then we have the last value is 1. 1 is collecting 1, 1, 1, 1, negative 1, negative 2. Here we are. Then we have this value collecting 1. Here we are. 1 is collecting 1. Then 1 again. 1 is collecting 1, 1. then minus 2 and a 3. Then the middle value is collecting the outside values 1, 1, negative 1, and a 3. Then the last value is collecting 1 minus 1, 1 minus 1, and also 1 and a negative 2. This value is collecting 1, 1, negative 1, negative 2. Then this one is collecting those values. So negative 1 is collecting 1, 1 again, then you have 1 again, then negative 1. Then this negative 2 is collecting 1, 1, 1 minus 1. We have 1, 1, negative 2 is equal to 1, 1, right, negative 1. Then the last one, 3 is collecting with a 1 here and also a 1 here, then a 1 and a 1. So now we want to find the determinant of the first matrix and also the second and third. First, second, and also the third. First, second, also the third. We want to find the determinant of those two matrix of this given matrix M. So we are saying 1 by 3. 1 by 3 simply means is 3. So 3 is subtracting minus 2 times minus 1. So 3 minus 2 here is 1. Let me use black pen, black marker, so that our solutions will be visible. So 1 by 3 simply means is 3. So 3 is subtracting a 1. So 3 minus 1 is a 2. Then 1 times negative 1 simply means a negative. 1 times a negative 2 simply means a negative 2. A negative 2 minus minus a 1. Minus 2 minus 1 simply means it's negative 1 here. Then here we are, 3 is subtracting 3 minus 2 simply means it's 5 here. Then here we have 3 minus 1, which is 4. Then minus 2 minus 1, minus 2 plus 1, which is negative 1. Then the last one, a negative 1 is a negative 2. Here, a negative 1, a negative 1 is a negative 2. Here, 1 minus 1 simply means a 0. So now we have, so what we have now is we have 1, 2, minus 1, 5, 4, negative 1, a negative 2, a negative 2, and a 0. Right. So now we want to so now we have these values from finding the determinant after applying the method of this method of cofactors, right? Finding the cofactors, we have calculated the cofactors. So now we want to find the matrix of minus. So for us to find the matrix of minus, what you are saying is, for us to find the matrix of minus, we are using this matrix, right? We are using this matrix. We are using this matrix. Now we have a 1, a 2, a negative 1, a 5, a 4, a negative 1, a negative 2, a negative 2, and a 0. Want to find the matrix of minus. So for us to find the matrix of minus, simply means we are multiplying by a positive and a negative, positive, a negative, a positive, a negative, positive, a negative, a positive. So we are finding the matrix of minus. So we are saying this one becomes a positive, right? This one becomes a negative 2. This one becomes a negative 1. This one becomes a negative 5. Again, this one becomes a 4. This one becomes a 1. Simply means negative by negative is positive. So a negative is a minus 2. This one becomes a 2. This one becomes a 0. This one is matrix of minus. Remember, we want to find the inverse of matrix M, right? But now we have the matrix of minus UER. So let's find the transpose. We are saying M to the power of T. We want to find the transpose. So transpose, what does transpose mean? Transpose means just changing the rows in columns and column into rows. Simply means this is how to find the transpose of matrix M. We are changing this rows into columns and also rows into columns and column into rows. So we are saying instead of writing 1 minus 2 minus 1, we are changing them from rows into columns. So we have a 1 here, a negative 2 here, a negative 1 here. Then we have a minus 5 here, we have a 4 here, we have a 1 here. Then we have a minus 2 here, then we have a 2 here, we have a 0 here. This one is the transpose of matrix matrix M. The transpose of matrix M after finding the core vectors and also the minors. Right. Now we have what you call the transpose. We have the transpose now. So since we have the transpose, what you have to do is we already have our matrix, the determinant of matrix M, which is negative 2. Since we have implemented hence part, we want to use hence part in order to find the inverse of matrix M. So implementing hence part, here is our determinant of matrix M, right? So we want to find the inverse. So we are saying the inverse of M is equals to a 1 over a determinant. A determinant now is negative 2, right? It's negative 2, right? Then here is our transpose. So we are saying a 1, a negative 5, a negative 2. Here is a negative 2, a 4, a 2, a negative 1, then a 1 and a 0. So here is our inverse of matrix M. So you will be awarded 5 marks for that. So usually this one is the best way to find the inverse of matrix M. Then let's move on the last part. State the name given to the matrix with determinant which state the name given to the matrix with determinant 0. Right? Since when a matrix is determinant 0, simply means that matrix is called what you call a singular matrix. A matrix with a determinant 0, we call it a singular matrix. So this one is the name given to the matrix whose the determinant is 0. So here we are. This one is the name given to the matrix whose determinant is 0. So please guys, as I said before at the beginning of this video, after watching, please don't forget to subscribe. If you like, comment and also share this video. Usually, if it's your first time, just subscribe. So this one is the best way in order to find the determinant of matrix M, also the inverse of matrix M, and also to state the given name of the matrix whose determinant is 0. So thank you guys. Thank you for being together on this simple lesson on finding the inverse of matrix. Thank you so much.